To demonstrate an example of a transformed cosecant function, we have y is equal to 4 times the cosecant of 2x. Now what I'm going to think to myself is the cosecant is the reciprocal of the sine function. So if I can draw a transformed sine function and then apply the very important mathematical concept of boop, then we should be in great shape. So what I'm going to do is try this out. For our amplitude modulation, we're going to multiply the y values by 4. And for our frequency modulation, I'm going to multiply my x values by 1/2, simply the opposite of whatever I see in here. So I will start with the values that are associated with the sine function, and then we'll worry about transforming those. So for the sine function, this would be 0, 1, 0, -1, and 0. Hoping that's starting to look quite familiar. We have one horizontal and one vertical transformation to apply. For the frequency modulation, we're multiplying all of our x values by 1/2. So we take half of each of these to get 0, pi over 4, pi over 2, 3 pi over 4, and pi. Also letting us know that one period will go from 0 to pi. For the amplitude modulation, I multiply all of the y values by 4. So in purple, I'm going to draw the graph of the sine function. Uh-oh, we might be struggling to get 2 full cycles in here. Oh boy, oh boy, okay. Mark off +4 and -4. I mentioned before that the majority of these graphing trig functions problems is simply going to be sketching the exact same graph over and over, just with different x scales and y scales. So this will be pi over 4, pi over 2, 3 pi over 4, and pi. Or consequently, we could also call them pi over 2, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which lends itself to 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. Now, to create a cosecant function out of a sine function, wherever the sine hits its midline, we draw a vertical asymptote. Wherever in between any consecutive asymptotes, we will apply the principle of boop. We're going to go ahead and boop that sine right on the snoot, and then run back off to infinity. Boop it on the snoot, run off back to infinity. Boop on the snoot, run back to infinity. Boop on the snoot, run back to infinity. Now, as far as the domain and range for this function, I notice that at 0 pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2, that we wind up with vertical asymptotes. That's any multiple of pi over 2. As far as the range is concerned, the lower parts have a maximum value of -4 and then go down to -infinity. The upper portions have a lowest point of 4 and then go all the way up to +infinity. That is how we come up with a complete graph of our cosecant function.